So in section 3.3, we did one of these graphs where both graphs were given and we had to work backwards. In this section, they get a little bit more complicated because now we have both stretches and translations. So they've given us the graph of g of x, and they've told us that it's the image after something's happened to f of x. So what we know is we know, for example, point A on f of x, which is at 0, 8. Something happens to it, then something else happens to it, and we end up at a prime, which is now at -2, 0. And point B, which starts off at 2, -8, something happens to it, something happens to it, and B prime ends up at 0, -8. So I don't know if you remember with the one that we did similar to this in section 3.3, that you could just see, because there was only one arrow, you could tell what you needed to do to get to the other point. But now that we have stretches and translations possibly happening, you could guess, hey, maybe I just need my 8 to stay the same and then go down 8. That works for the first one. But if I try it staying the same and going down 8, it doesn't work for the second one. And you might be here a long time if you just try to guess and check what could work. You might get lucky and get it right away, but often you're going to be guessing for a long time. So this is where I showed you that second technique on that last example, where I said for that last example it actually is more work than the original just looking at the arrows, but for this one you're going to need to use it. And that second technique said, let's start by looking and comparing the horizontal distances. On our red graph, when you went from A to B, well, I'm starting at 0 and I'm going 2 to the right, so my horizontal distance is 2. Just looking at going from A to B. And then you take out your blue graph and say, what happens from A prime to B prime? Well, we start at -2 and we go to 0. So again, we're going 2 to the right. So both of them have a horizontal distance of 2. Nothing's changed horizontally. You could write here, if you wanted to, that you could multiply x by 1, but you wouldn't actually show that as a transformation. We do the same thing with our vertical distances. And so looking from A to B, well, A starts off at +8 and B is at -8. If you went from A to B, you would go down. So we're going to show that as a -16 because you're going down 16 units. The direction is important because sometimes one of them might be going up and the other one going down, and you have a reflection involved. When you look at A prime to B prime, well, now A is starting at a y value of 0 and going down to -8. How would I go from -16 vertical distance to -8 vertical distance? I would have to multiply y by 1/2. Now that you figured that out, you can put, these are your stretches and compressions. So you can put them above the first arrow. Because normally we would write, oh, we need to multiply y by 1/2. We normally don't multiply and show x by 1, right? You can write it down if you really want to. If you feel really good, like, okay, I'm going to test out my multiplication skills by 1. 2 times 1, nailed it. 0 times 1, yes. Feel good? Okay, our x values aren't changing. because they're getting multiplied by 1. But our y values, if y is being multiplied by half, then 8 is going to go to 4, and negative 8 to negative 4. Once you have those middle points, now that you only have one more arrow to go, it's going to be easy to label what needs to go up here. You're at 0. You go to negative 2. How could you possibly do that? With a translation. You need to go 2 to the left. Does that work for the second point as well? Do a check. It does. How could I go from 4 to 0? I'd have to go 4 down, minus 4. Negative 4, 4 down, does that get us to negative 8? It does. And so by first doing those horizontal distances and vertical distances, you can figure out what needs to happen on this first arrow, which will give you these second points, and then figuring the translations after that will be easy. And once you've written all of these things down, we can now write the equation of the blue graph. And it says, write the equation for the image graph in terms of the function f. Where will this 1/2 be? Outside the function. Then 2 to the left happens inside the function. X plus 2 and the 4 down outside of the function. Okay? And then it says verify. Well, the way that you would verify would be to put in the point on the red graph, do the transformations, and check that it comes out as the right point. So instead of redoing our work, at this point I might actually just go and write verify here, the work I've already shown, and then I don't have to redo it. Because that is the verification, to show that the point A goes to the point A prime. The point B goes to the point B prime. And so we have done that already. Our technique was sort of a verification at the same time. Okay, so try question number 9.